Hi students, my name is Sebastian. I'll be your instructor for this semester. I'm super excited to teach you. We have a session now where you, as you know, could submit questions and I'll do my best to answer them. But I want to mostly welcome you first to class and looking forward to interacting with all of you.
Thank you for being here, Sebastian. Really appreciate you answering our questions. And so the first question comes in from Radu. The question is, there's been tremendous progress in AI, and now the applications seem to improve asymptotically to the point where common sense is needed. For instance, speech recognition works well in most cases, but fails for some cases that would have been easy for a human to infer from context, from semantics, from logic, etc. Of course, common sense means in fact everything that the average human knows, so it's one of the biggest problems. Do you think common sense is needed for cars to become fully autonomous, or can the current technology cover all the important requirements?
So, well, first of all, I agree on the common sense issue. And it's one of the most difficult things in AI has been to build a platform that kind of can deal with many things. What AI has really proven to do recently, mostly machine learning, is to build things that are very specific. Like, for example, we just had a Nature paper show up on detecting skin cancer. Google earlier last year defeated the world's best Go player. But this Go program cannot play chess. And our self-driving car can't fly an airplane. So there's certainly a gap here between human cognition and machine intelligence. I do, however, kind of a question about self-driving cars, believe that the current skill of the Google self-driving car has already exceeded the human driving skill. And while there's still situations that are funny impasses where a human would judge much smarter than the car, the human driver is also distracted and texts and drives drunk and all this stuff, that in totality the car does already better than people do. So I think we should not confuse the AI system with a person. The thing the person can do better. And one of the great research avenues for future AI research would be to figure out, can we give a car enough common sense to deal with situations that are completely out of the playbook?
You mentioned that gap. Do you ever think there'll be an AI that can bridge the gap and be smarter than humans in all different kinds of situations?
There'll always be the future, and we're always going to move on. The reason why I should say yes, we will get AI systems that are broadly smart at some point is because AI just evolves faster than human brains. Like if an AI learns something, then all the future instantiation of, say, the Google self-driving car are born with the complete wisdom of their forefathers. It's almost like if kids are born with a high school diploma or speak all the languages their parents speak, whereas humans have to do this over and over again. So in the end of the day, I think we're going to crack that nut, in my opinion.
Thank you for that, Sebastian. This next question comes in from Nicholas. He asks, what outside projects do you think you should complete in the world of AI or autonomous vehicle technology that are widely accessible in order for him to begin a career in the area? He says most autonomous car and drone technology companies want prospective applicants to have at least 2 or 3 years of related experience. But as a full-time engineer in a slightly different field, it seems difficult for him to make the jump to AI or UAS. What do you suggest he does to facilitate that jump?
First of all, I would very strongly suggest to take the Udacity self-driving car nano degree. And the reason is that's really built by industry to get people a job, and we have extremely good job placement statistics so far. In terms of experience, you can also go to Udacity and participate in the competitions. We issue competitions to students, and if you do well in those, you have an even better chance to get a great job. Short of this, there's areas that are actually really, really fascinating right now that are really easy to implement. For example, up and coming is the idea of intelligent homes, right? The home that recognizes you, right? So you could take your phone and just mount it in the entranceway and see if you can build an AI that recognizes you and maybe gives even statistics of how when your sister showed up or your parents showed up or whatever it is, your kids showed up, whether your dog jumped around enough today. That doesn't require anything that you have to buy because all of us have smartphones.
Thanks for that, Sebastian. This next question comes in from Glenn. He says, I know in previous videos you mentioned that snow and ground coverings are an issue. Is this still an open problem, or has there been a lot of work done that has come close to solving the problem?
So I've not been in touch with the Google team, or the Waymo team I should say, about snow lately. And this is the first year in California where they have a chance to test snow. Okay. In past years, it just didn't snow very much. Last 5 years we had a drought. I think it's an issue because, from my understanding, because it doesn't fall into the operating scenario that Google has chosen, which is right now they're driving a lot of Mountain View here. But it's not a hard issue. It's not an insurmountable issue. It's just something, just like construction zones that take time to work through and that can be solved.
Is snow one of the greatest problems being faced, or would construction, for example, be a bigger issue?
What I found when I ran the Google team is that the biggest issue is this myriad of things that can happen that by themselves are extremely unlikely, but in totality happen quite frequently. It's the couch on the highway. It's the deer in the headlights. It's the plastic bag blowing across the street, looking maybe like a big obstacle. The tumbleweed. It's snow. It's rain. It's the broken sensor. And all these things in itself are very unlikely. But if you don't deal with those, you might have an accident every few hours or every few days.
Thank you, Sebastian. This next question is from Kausalya. Does each car manufacturer build the self-driving software from scratch, or are there SDKs? How much customization is possible in those? For instance, in India, driver's seat is on the right-hand side, and thus most of the rules have to change to this perspective.
So I sense two questions. First, about automotive companies. Every automotive company that I know of has made building self-driving cars one of the number one priorities, and they're all staffing up internally. Having said this, NVIDIA in particular, one of our hiring partners in the self-driving car category, they now building a platform, and they want to sell their compute hardware and software into car companies, and they already have many deals going. Waymo recently announced publicly that they shifted the business model, this is the Google spin-out, from building a taxi fleet type situation or competing with Uber into becoming a tier one supplier for car companies. Now, these are just announcements so far. We have to see how it materializes. I can tell you the demand for engineers with self-driving car skills is enormous. So if you were to take our nano degree, then you'll be hired, hopefully in a heartbeat.
You mentioned Udacity's hiring partners. Can you tell us a little bit about the hiring partners?
Yeah, so unlike in the Georgia Tech degree, which is academic, and it's phenomenal in my opinion, when we work at Udacity with nano degrees, we tend to go to companies and say, what would it take for a student to be hired? And when you ask that question, then you get very succinct answers. Like you get an answer, for example, from Mercedes saying the following 8 skills. Like it has to be able to deal with multiple sensors, sensor fusion, understand carbon filters and show that it can do it, understand deep learning, understand this and that and that. Okay? And then what Udacity does, it just turns that into a curriculum. So our curricula are built by or driven by industry demands. And as a result, when our students come out, they have those projects that they can show, that they build something, and they can show these projects to employers, and employers like this in general. So that's our model. We have, for the self-driving car degree, over 30 announced hiring partners. There's more to come. And these are the leading companies in the Valley that are willing to hire those people.
Thanks for that, Sebastian. This next question comes in from Pedro. It's a general question. He says, how would you personally define intelligence? And in a brief statement, how would you define artificial intelligence?
Boy, intelligence is a thing that I lack, okay? That's the reason. You always work in a field where you have your own deficiency, and I picked artificial intelligence because I wanted to boost my lack of natural intelligence. This is one of these philosophical issues. I mean, consciousness is maybe the hardest term to define ever. Is a machine conscious? But I would argue we can measure intelligence. We can measure intelligence, at least in certain levels. I think we can distinguish a good from a bad chess player. We can distinguish a good from a bad Go player. We can measure how good a conversational chatbot is in achieving its objectives. In our new Nature paper, we're able to measure how good an artificial intelligence dermatologist is able to find skin cancer compared to a human dermatologist. And while these are just one-dimensional measures of one specific skill, and they're not the beauty of the broad human intelligence, they're still indicative of how far the field is pushing. And what I see in pretty much every narrow field of work that is repetitive, office work, from legal paralegals or legal lawyers doing document drafting or legal discovery, to medical doctors, radiologists, dermatologists that do maybe diagnostics, all the way to accountants, that the frontier of AI is now really surpassing kind of human level skills for these highly repetitive tasks.
And this next question comes in from Santosh. Some of the industry experts recommend having a separate lane for all autonomous self-driving cars to avoid accidents, similar to bike lanes for bicyclists. So what is your opinion on this suggestion?
That to me is like politicians and regulators being ahead of themselves, and they should just not say this. Because, I mean, everybody wants to make a contribution, I get this, and everyone wants to make a proposal, I get this. But the reality is, when you look at the data of self-driving cars today, they blend into traffic just fine. So why would we give up an extra lane for them? First of all, we don't have very many of those, and once we have them, they're just going to blend in. Much smarter to have them blend in. So I'm careful with these projections. I think we build technology that fits in well into existing traffic and just leave it there.
I suppose the flip side to that question then is looking 75 or 100 years in the future. Do you think there'll be special lanes for human drivers because the AI and autonomous vehicles will be so much safer?
I think 75 years from now, there just won't be any lanes, period.
What do you think there'll be?
I think we're going to fly as opposed to drive. I mean, flying is much more economical. It's much faster, much safer, much cheaper than ground transportation. I think this is going to be transient. When we figure out how to build flying cars, we're going to abandon regular cars.
Have you ever seen the film Blade Runner?
Yeah.
Do you think the flying cars of the future will be similar to the flying cars in Blade Runner?
Yeah, well, The Fifth Element is a better one.
Okay.
It's a beautiful one. Of course, there's a good amount of fiction in that specific movie. But yeah, I keep telling people that when they think about the future, that only 1% of interesting stuff has been invented yet, right? So we don't have a cure for cancer yet. We don't live twice as long yet. We don't have flying cars yet. But that doesn't mean we're going to have them in the future. When you think about real estate, more than half of the Los Angeles land mass is dedicated to cars today, or the highways and driveways and garages. If you had a flying system, you could just double the amount of real estate. Someone would get really, really rich doing this.
Mm-hmm. If you double the amount of real estate in the area, do you think you'll possibly double the population in the area as well?
It's very hard to get specifics. I think what's going to happen is with more and more transportation, the cities will become larger and larger because people love backyards and so on. So the outskirts of the cities, I think, where the action is going to happen, not the center of the cities. But yeah, if you took away all the highways and replaced them by apartment buildings, you could actually, out of the garages, you could probably double the occupancy of any amount of real estate.
Thanks for that, Sebastian. This next question comes in from Tyson. It is, do you have any example maps we can use on our own personal projects, or have you any ideas on how we could go about building one? They plan to mostly use camera data as input. They want to make the Power Wheels drive to the playground, kind of like an Uber for the kids. If they don't
That's
want
a phenomenal idea. Do it and send me a video. I'd love to tweet about it. It's a great idea. Please do it. Any student, please build something crazy. That is so great. The best way to impress me is to build something crazy like this, to be honest. Much better than passing a math exam. Maps, you can collect it yourself. If your vehicle is able to register itself to a map, then just drive the vehicle by hand the first time and you build your own map. Or you can go to Google Earth. Google Earth is a phenomenal source of maps. If there's no trees overshadowing a sidewalk, there's your map.
This next question is from Mirdad. I want to get into hardware of robotics. I do not know where to start from. How can I control a robot moving parts from a PC? For example, how can I control and send signals from a PC computer to a hydraulic cylinder?
There's tons of kits now available, typically based on Arduino. They can buy on Amazon, where you can get started with robotic work. Typically not hydraulic, typically it's electric, but you can have little robots zipping around. And I highly recommend starting with one of those and maybe spend $200 on it, which I hope, given the fees we charge for education, is within your financial range, and then play with it and then work your way up. Also, really amazing are these guys here. So if you hook those up to an Arduino system, you learn a lot about hardware. It's going to be frustrating, but eventually you can have a camera and almost like a supercomputer in your pocket.
And so this next question comes in from Jay. I was wondering how robust the self-driving car is with the unforeseen. It kind of goes back to what you were talking about earlier. Does the car know that letting go of the brakes or even speeding up, for example, could avoid an accident? Jay says, I remember an incident where a stopped car at an intersection was hit from behind, but if the driver had let go of the brakes, then lives potentially could have been saved. So, is self-driving development just working on following basic road rules, or is there also thought put into the unexpected, i.e. drunk drivers not staying in their lanes, deer suddenly jumping across the road in the middle of the night, making room for emergency vehicles to pass, all that kind of stuff?
So I can only comment on this to the point where I stopped running the Google team because I don't know what's been done lately in technology. But the answer is a mixed yes and no. The Google car, when I ran the team, drove very carefully and gave lots of space to other people. So for example, it would avoid on highways driving right next to another car in case the car wanted to change lanes. It would be very courteous on stop signs and happily endure being a little bit later by someone else if someone else wanted to run a stop sign. So it's a very defensive driver, and that worked out well because once you're being driven by a car that drives you, you don't want the driver to be as aggressive as you drive yourself, right? Now, when I ran it, we had no mode to anticipate someone else breaking the rules grossly, say hitting us from behind, and taking the appropriate action. And that's something that certainly would be fun to build in. If you look at the accident statistics, when I ran it, we had 0 accidents caused by the self-driving car, but many caused by people. And a good number of those were actually people bumping into us at a red light. So that or at any kind of situation where we are standing still. So that's certainly something that would be fun to build. I'm not sure the build team has done it or not. I don't know.
Thanks for that, Sebastian. The next question comes in from Spyrodon. Could you please discuss how recent advances in deep learning and GPU computing have impacted autonomous vehicle research?
Quite a bit. I believe that the self-driving car research is now flipping over from a much more probabilistic approach that we invented something 10 years ago when I published my book to a much more machine learning approach, even more so than we did it back at Google. And the reason is the advent of deep learning. And NVIDIA as a company has bet on this, and they're really pushing it really hard. So they're pushing the GPU as a preferred compute platform into this deep learning space. Again, at Udacity, we teach self-driving cars. We have competitions, and our students start with deep learning as the first course, which is amazing. And they produce code using deep learning. And I can tell you the software that our students have developed, the best teams have developed, has thoroughly impressed me. We've been able to take our car out and do amazing stuff with it based on software that students developed. So if I were to place my money right now, my bet right now, I would place my money squarely on machine learning and deep learning over anything else.
And so the next question comes in from Tyson. How do self-driving cars today handle the trolley problem? And the question goes on to define the problem as, it's a situation where the car must make a decision and pick who lives or who dies in a fatal accident. So they're saying, I assume that when the scenario happens, the car will default to making the human driver decide. But suppose someday in the future we have truly autonomous cars and humans are actually deemed less safe than letting the car decide. Who decides then? And so what Tyson wants to know is, are people having these kind of conversations today?
It's a very simple answer. The car will just avoid those problems. It'll just drive in a way that never gets stuck in a dilemma like this.
Very good. Okay, well, thank you so much for that, Sebastian. I know you're incredibly busy. I think we just have time for one final question. And this one comes in from Yagnesh Kumar. And the question is, what are some key challenging problems in AI today? And can you provide a brief overview of state-of-the-art research and where you think it is going?
So we have a lot of progress in machine learning lately. And I would argue machine learning is now being used to image processing, video processing, speech, language, natural language, very successfully, to the point that almost any repetitive task, you can build an AI that sits there carefully and watches people do it and eventually make people 2, 3, 4, 5 times as efficient or possibly take over. The significance of that is that 75% of Americans work in offices doing repetitive work. So at some point, that might actually be as significant as the agricultural revolution, where we made people 100 times physically as strong as they used to be with machines. The state of the art in AI is phenomenal when it comes to machine learning and lags behind a little bit when it comes to general intelligence, doing many tasks. And we have a fairly poor account how to kind of fuse very, very different types of data sets. Like, for example, when you get a PhD, you read a lot of books, right? And you do stuff with your hands and blah, blah, blah. And somehow your brain fuses all that stuff when you have conversations. Books are full of rules and wisdom that's actually really important. When we build the world's best Go player, I don't think we go and read books. Or when we build a self-driving car, we don't read books about it because we don't know how to understand language in the context of self-driving cars. So to some extent, the work is very silo. Like every piece of AI success is focused on one thing, and we have not been able to build a good platform that would go across many, many tasks.
And a follow-up question to that is, what do you think is the most important characteristic or biological learning process that needs to be incorporated into artificial neural networks?
I think we've just cracked the nut on one thing that was uniquely human in the past, which is deep learning. We are now able, so I'll give you an example. We just had, as I mentioned, a Nature paper on skin cancer. Mm-hmm. And we trained a deep learning network to understand what a carcinoma is and what a melanoma is using about 130,000 images. And that's more than a human physiologist will ever look at, but it's small by internet standards. Mm-hmm. And when we did this, it didn't work very well. So we then ended up saying, why don't we pre-train the entire network on something completely different, like cats and dogs? So we took Google's TensorFlow, which we use in teaching in Udacity, and pre-trained it and used this pre-trained network as a way to kind of shape up the behavior for skin cancer recognition. And while you might say cats and dogs are really completely irrelevant for finding melanomas, mm-hmm. they gave a huge boost to classification performance because the neural network had developed feature detectors in this other domain that were useful for many other domains. The fascinating thing for me is I worked in neural networks all my life. My master's thesis was in neural networks, my PhD thesis was in neural networks, And back in the day, we couldn't do this. We all wanted to do it, but we couldn't because the data was too small, the computers were too small. I think in hindsight, we probably used to work on something the size of a frog brain, and now we have a human brain. And just by going to a larger system with more data and more compute power, we've been able to get an unbelievable amplification of what these systems can do. Well, thanks for asking such interesting questions. I'm looking forward to the next batch of questions, and I'll see you in class.